So you may be asking yourself about the p-value. When it comes to the p-value, how low is low? How low? How low is low? What's a low enough p-value to reject the null hypothesis? Because remember, the rule is if the p-value is low, reject the hoe, right? So how low is low? Well, it's a tough question. It just sort of depends on what's at stake and who's doing the deciding. And that's sort of the end of the story. Sometimes when people do statistics, they're bound by a contract or some agreement or whatever to reject at some that you could take some threshold. You can maybe your boss says, I want you to reject these null hypotheses if the p-value is less than alpha. So alpha is taken to be what we call our significance level. This is the same alpha we saw before when we were doing confidence intervals, and we said that the confidence level was equal to 1 minus alpha. We'll see the connection there later on. But alpha is called our significance level, and you can think of this as a threshold. Okay? Reject, do like this. You reject H naught in favor of HA if the p-value falls below alpha. Okay? That's the idea. Okay? So a lot of people aren't comfortable with just getting a p-value and then making a decision. A lot of people do it that way. Okay, it's perfectly legitimate. But sometimes, your boss, manager, or something might want to prescribe an alpha level. 5% is common. Okay, so that if the p-value falls below 5%, then reject the null. Okay, 5%, 3%, 1%, 2%. Those are typical values of alpha. Something small, 1, 2, 3%, something like that. All right, so let's suppose that we're getting ready to do a right-tailed test. That is, our null hypothesis is that mu equals mu naught, and our alternative hypothesis is that mu is greater than mu naught. So I know that the central limit theorem basically says, let's be an easy way to think about it. Central limit theorem says that our sample mean is going to basically behave sort of like this. This is behavior of the sample mean. Okay, where here is mu naught. This is if the null hypothesis is actually true. Okay, the sample mean, x bar, that's what it is. It's going to bounce around mu naught, right? Sometimes it'll be here, sometimes it'll be over here. Rarely, but sometimes it'll be over here. Sometimes it might be down here, but usually it's right in around here, right? Okay, good. So the idea here is that if we come up with some significance level alpha, like I don't know, like 5% is a typical value. The idea is that we want this area off in the right tail, right there, to be our significance level alpha, like 5%. Okay? That is because remember what we use alpha for is sort of like a threshold, right? We're going to reject the null hypothesis in favor of the alternative that the mu is actually greater than mu naught, provided our sample mean falls over in this region. Okay, if this is the behavior of the sample mean or the null hypothesis, if it falls far enough over to the right, we'll reject the null hypothesis in favor of the alternative. And so, if we stipulate that alpha equals 5% or something like that, then we can find this point here, this sort of threshold cutoff point, and then if x bar crosses over that line, then it's then we reject the null. Now, there's there are a couple things that could go wrong here. One is the null hypothesis might actually really and truly be true, okay? And then by chance, it's possible that you see a statistic that's this extreme that falls over in this region. So when that happens, the chance of that happening is actually alpha. And you don't want that to happen if the null hypothesis is true, but it certainly could. And so alpha is sometimes a good way to think about this is the probability of making type 1 error. You see, let me draw this little chart here. It's in the notes too, but a similar one anyway. You have a couple things that could happen here. It could be that the null hypothesis is true, or H naught is false, right? And it could be that so when you run this test, you're going to do one of two things, right? You'll reject H naught, or you'll fail to reject H naught. Never accept H naught, by the way. You either reject it or fail to reject it. You never want to accept anything, especially from strangers. But okay, so if you run this test and you get a sample mean that's over in here, then you're not gonna reject H naught, right? And if H naught is true, then you've made the correct decision, and that's good. Also, if H naught is false and you run your test and you get a small p-value and whatever, and you reject H naught, then you've done the correct thing here too, right? But there are a couple ways to screw this up. If H naught is actually true, if the mean really is mu naught, but then you reject H naught, that's what we call type 1 error. Okay? If H naught is false and we fail to reject H naught, then that's also an error. We call that, guess what? Type 2 error. Okay? All right. Now, so what does type 2 error look like, or the type 2 error probability? Well, we aren't going to focus too much on that because it sort of gets a little complicated, but beta is the symbol for the probability of making type 2 error, and it really depends on the actual value of the mean. So I tell you what I'll do. I'll just draw another curve here. Okay, let's suppose that this right here, this guy, mu A maybe, is the actual living, breathing mu. Okay, it's the actual, real mean mu. Okay, then actually this is the real behavior. This is the true behavior of X bar. Okay, it'll bounce around in here. Okay, occasionally be over here or occasionally be over here, but tends to bounce around in there. Now, type 2 error occurs when H naught is false and you fail to reject H naught. So here I've got H naught is actually false because the true mean is here. But when will you fail to reject H naught? Well, you're only going to fail to reject H naught if the sample mean falls to the left of this same mark. Because remember, this mark is sort of your threshold, right? This is our threshold. So the chance that you make type 2 error is the chance that your sample mean does not cross over that mark. So all of this stuff in here, this stuff, all of this is beta. Okay, that's your probability of type 2 error. Okay.